Thank you all for staying for the last session of the day for the executive track. This is the place to be, definitely not at the bar. Nobody is at the bar now. In fact, the bar doesn't open until 5:15. So that's a good idea. I'm going to work on that. Right, that is a great idea. Definitely CEO thinking over there. So it is my great pleasure to introduce Mr. Ken Couch from InterSystems. And so Ken is going to talk to us about the journey at InterSystems, migrating or moving their applications from on-premise to the cloud to take advantage of SaaS and CI/CD and continuous integration. And so as anyone who is undergoing that journey or has taken that journey knows, that's quite an undertaking, quite a project. So Ken is the Chief Enterprise Architect at InterSystems, where he leads a team of architects who are responsible for many large enterprise platforms and several SaaS cloud-based offerings. So please join me in welcoming Ken.
So let's talk a little bit about InterSystems and what we do, because I think it'll help describe when I talk about the technology and our challenges. It'll give you a good view of here's the problem space that we're in. We're an ISV. We've been doing enterprise receivables management for around 30 years. And that means that anybody who has hundreds of thousands of accounts of people that owe you debt, we help you get that money in. So that's kind of where we live. And that's large things like credit card companies, large hospitals, governments, that kind of space is where we work in. And because we work with those type of entities, we have HIPAA data, PCI, all the kind of ugly stuff and regulations that you have to deal with, we deal with. And we have several core enterprise products, all built upon InterSystems technologies, 10 to 20 to 30 million lines of code apps. Some of them have been around for 30 years or more. And that's kind of where we live and what we've been living for a long time. About 6 years ago, we started a journey to move towards a SaaS platform. I'll talk a little bit what that is, but we learned a lot of lessons, and I think a lot of them are applicable to everyone moving to this space. That's what this talks about. If you have questions as I go along, please feel free to ask them. We don't have a large group. To the end, I'll also have time to ask questions as well. So this is a good example of what we have or had in the past. We have multiple premise customers. Those premise customers run various versions of our various applications. So premise A has application 1 and application 2, and they're on different versions, which is different than a different premise customer. And that causes a lot of the typical problems that you'd see there, where a customer 1 doesn't want to upgrade or doesn't want to upgrade this month. And how do you ship them a new release? And how do you keep all that in sync? How do you fix the bugs? How do you deliver innovation? So we're running into a lot of these problems, right? Slow time to markets, slow rollout to customers. And because we have multiple applications written in different code bases, we are often rewriting the same feature multiple times. Kind of a big problem for us. So our plan was to let our customers keep their applications. We didn't want to have an event where they could choose to migrate to a different application, but we wanted to start to integrate those various versions and various applications into our cloud. So we wanted to build a new multi-tenant SaaS with multiple services in the cloud that all of our core applications tie into. So our customers will still log into those applications, but now they get new features delivered via SaaS. And we wanted to go ahead and do some of the things that cloud allows you to do, like support a single version versus having possibly 5 to 10 years of various versions on premise. Solves that problem. So some of the benefits that we have for SaaS over premise, from a technology point of view, a lot of we get one target environment. It's not Windows and Unix and Linux and everything else. We get one shared code base. We can scale up or out as needed, and we can easily adopt new technologies. From a business point of view, a lot of it's around we can get our new features to the market a lot faster. We don't have to wait for the customer to upgrade. We don't have to wait for them to get on a specific version of a platform. We don't have to focus as much on running our core infrastructure in the cloud. We let AWS or Azure run that. And then we get physical security and multi-region. So we're able to scale across the entire United States for our software and our hardware. So what is SaaS? For our definition, we've stopped using the word cloud because it's ending up not meaning a lot to us anymore, and we start talking about SaaS. And for us, it's these four things. It's multi-tenant. We want our customers to utilize the same infrastructure, and we want to kind of maximize the shared usage of that. It's all API driven. Everything's a service. It's scalable, both horizontally and vertically. So as needed, we can scale up or down. And then it's fault tolerant. So we're up, hitting our 99 uptimes. So multi-tenant. Some of our first questions we had on multi-tenant are, how are we going to store the data? What does that mean? If you got a multi-tenant structure, you could store all the records in the same database, in the same table, and you could have a column in there that says, this is for this tenant, and this is for another tenant. Or you could store them in different tables, or you could store them in different databases. How do you do that? Another piece is, how are you going to handle tenant processing? So when you add more tenants, what does your load look like? How do you scale up or down? And then actually, how do you define a tenant? Do you have a tenant storage system? Do you build it? Do you try to go buy it? How does that work? And we've evolved our approach over the past 6 years. So this is where we started, where we have an API layer that talks to a routing layer. It doesn't really matter. The middle part is kind of the important piece, where we have separate services for every tenant. So every time a new tenant signs up for a cloud service, that means we have to spin up new VMs, new backend services, new microservices, new whatever else. And we also started off with having just a single database with all of our customers' data into it. And then we use row-based security to say, when I do a select statement, I get this tenant's data versus another tenant's data. We ran into a lot of issues with that. Number one, it was hard to scale. You had to keep adding more and more services for every tenant. And if a tenant didn't use all the services, you still had to pay for them, right? You couldn't really share that infrastructure very well. And when we started using our database and using BI and cubes and that sort of stuff, having those all in a single cube is a lot more difficult than having a row-based SQL-type access. So this is where we moved to. Now we just have a set of shared tenant services. We don't spin up new ones by tenant. All of our code actually will run against any tenant. So every time we get a call in, we actually look up who that tenant is, and we reference that configuration information and run it. That means we just scale based on demand. So if we have low demand, we have a low number of services. If we have high demand, we scale up, and there's no specific tenant type information. Since we live in the PCI HIPAA world, we also switched our database library. Instead of having one single database, we actually create a new database per tenant. They actually have their own SQL. So we've got a layer between us and the applications that allows our commands to be ran on the correct database library. That makes it really easy to talk to security type people. So for us, what we learned about multi-tenancy is that we prefer having code that's not tenant specific. So we don't want to submit up a service every time we get a new tenant in. And for us, we prefer storing data in separate schemas, not in the same table. And because we're in the PCI HIPAA environment, we actually have separate databases as well. That's worked out really well for us. API driven. We're a set of services. We're really driven by our API. We chose JSON and REST over SOAP, but go and pick out what that is. We spend a lot of time agreeing on and then enforcing standards. Depending on your engineering team, they can get into religious wars about what REST is and what JSON is and what verbs you should use. So having that all defined and documented and enforcing that really moves your development process along. And then we started building our APIs. So an example of one here is send SMS message, where you give it a phone number and a message to send. That seemed pretty innocuous. It turned out it wasn't. So we started thinking about API granularity. When we expose send SMS with a number and a message to our consumers, that means our consumers had to figure out all the other stuff around it. Like, when should I send the SMS message? How do I keep a history of it? What's my rate limiting? How do you deal with errors? There's a lot of business processes that's more complicated than just sending your SMS message. So we define these things called fine-grained APIs. They're pretty small functional units that are easy to integrate into, but they put a lot of the business logic back on the consumer. So coarse-grained APIs. This is where we want to move to, and we've started defining our APIs. And these are larger APIs that encapsulate more of the business problem. that means that you have to understand the business problem, right? And that means your engineers have to understand the business problem and the product folks. It removes a lot of the complexity from the API consumers. So if we look at the bottom of this, instead of having a send SMS, we now have a contact by SMS API. Where you still give it a phone number and a message, but then maybe you give it some more information, like stop contacting it by this date, or here's the regulatory data you need to worry about when you're sending this SMS message. And all that logic then happens in the cloud. And it's about as complicated as the previous one, but since we know the problem domain and the business domain, we add a lot more value to the consumer with this API than with the previous one. So when we talk about API definitions and what we expose, we always try to push towards coarse-grained APIs versus just fine-grained ones. So lessons learned, we talked about we prefer coarse-grained. One of the other big things is to think about the leverage and the size of the API. So I just brought up there, send a message or contact by SMS. Well, that's still kind of small, right? It could be just contact this person. Let the platform figure out, instead of send an SMS, make a phone call, send a text, send an email, whatever, right? Let it decide. So always be thinking about what the right size of the API is, and always challenge when you see that. And it's not just a technical problem, right? It's a business problem. Because once you become a SaaS service, your API is your business, and what you expose determines your strategy and how your customers actually use your systems. So scalability. Obviously, we want to be able to scale our services up and out. For us, that means that we've leveraged Docker, and it's the only way we deploy anything in the cloud, whether it's InterSystems or something else. Kubernetes and auto-scaling. We've been running that pretty successful for a while. Our core premise applications are those 30 million lines of code InterSystems applications. Those tend to take a really long time when you get a new engineer in for them to learn how to code that sort of stuff. So we wanted to move away from it. Also take a really long time to test. So we started to moving towards a microservice architecture, which are small things that just do one thing that you can typically bring a new person on, and they can learn it hopefully within weeks instead of years. So in this example, we talked about an SMS message. We'll have an SMS API, but behind it we'll have things like an SMS rate limiter, which deals with how fast you can send SMS messages out because there's limits for carriers. Or there's a program that actually sends the message out. So little small chunks that you can describe to actually deal with your entire business problem. And when we got there, we started talking a lot about this. And this is actually an industry term. It's not exactly politically correct, but it's memorable. And once you start talking about, people understand. When you talk about your services, it's helpful to think about them in two ways. One is that you have pets, that you have names, that you love. And when they get sick, everyone stops what they're doing and tries to help them and bring them back to health. Then you have cattle, which don't have names. And when they get sick, you get a new one, right? And the idea is that you want to have a lot more cattle and very few pets. Because when pets have an issue in the cloud, everyone needs to stop what they're doing and bring them back to life, and it's a big deal. And when a cattle goes down, you just shut down that service and bring up a new one. Right? So one of the first topics we talk about when we create services is it a pet or a cattle? And if it ends up being a pet, we say, does it need to be a pet? Can we please make it a cattle? That type of thing. The other thing that we've done is we've done all the design for our scalability as far as here's how we scale, and then we put it into practice, and it doesn't actually work. It doesn't scale the way we want it to. The auto-scaling route didn't work. For some reason, the ECP connection didn't work, or so on and so forth. So not just doing like unit tests and functional tests, but doing scaling tests. So when you add a new tenant, does the system act the way you think it should act? Right? It's part of your regular automatic scaling. So fault tolerance. Again, applications survive failures without service interruptions. That's your 5 nines or whatever you're trying to do in the cloud. And this involves a lot of things. So load balancers, network design. We just talked about cattle versus pets, metrics and monitoring. A lot of those are really new concepts to most engineers who've just done kind of big monolithic applications in the past. So there's a lot of new concepts here of, how do you monitor? You need to monitor my application, or what does your network design look like? What's the latency look like? What happens when your latency goes over? So different kinds of conversations than you typically have for kind of an on-premise monolithic app. And what we found was one of the hardest questions we could ask was, how do you know if your thing is healthy? I mean, it seems like it's obvious, right? There's the obvious, this service is gone, it's not running, okay, that's unhealthy. But if it's impaired, right? So if we have an SMF service and maybe 10% of the messages don't go out, you consider that healthy? Should you kill that and create a new one? Is it 20%? Is it 30%? And again, that kind of goes back to the business impact. It's hard for an engineer to say this is healthy or not in an impaired state. The business has to say, well, once we get to this state, we're going to go ahead and drop this container and start a new one, or start a new service. So something that we're pretty interested in. Another lesson we learned is how do you inform your consumers? So on the right-hand side is AWS's, it's hard to see, a little blurry, is AWS's uptime. And if you've ever done AWS, this all looks green. And if you scroll through, you'll sometimes see a little tiny blue exclamation point, which happens to say like, hey, your region of S3 services or something else is out. But they're still green because all their whole region is up, right? So once you're multi-region, once you have multiple services, what does it mean when you have a part of your service outage? How do you report that back to your customers? What are they supposed to do with that information? All things that we've learned. Some of it's from AWS, which is one way to go about that. We've been a little more proactive with our customers as far as how we send out messages and talk to them about what the actual impact is. But again, not typical things that you do for an on-premise type application. So metrics and monitoring, obviously important if you want to be fault tolerant. And it's great once you start doing it. But we found out, how many do you really need? Which of these are critical? They cost money typically, right? Depending on how many you want to host and who's hosting them for you. And you have to make some other decisions, like do you want to push metrics out or do you want a platform to pull? So for example, there's a system called StatC that lets you push application metrics out to a metric monitoring service, or there's something like Prometheus, which will go query your service for metrics, some time period basis. It's important to figure out what you want to do and how you want that to work. Different platforms. Some metrics and monitorings around network aren't typically the right ones to do around applications, for example, right? So depending on what you're trying to monitor and what metrics you need, they could be different things. So here's some example of some shots that I took, I think last week, and I happened to catch some interesting information. So we've decided to kind of group our metrics into two categories. One's called application insight, which are the pretty charts that people want to go look at to know, well, how's the application doing? In this case, one of the things that we do is we do outbound dials, and we do about 2 million outbound dials a day, calling those people who owe them money, correct? And you can kind of see there on the bottom right here where we had a little dip, and you can see in the ping time on the bottom left over there as well, there we had a little issue, right? So you can kind of see business impact as far as here's how my services are performing. Looks like I have an outside of issue type here. Here's my application performance. How am I doing? Those sorts of questions, which is different than health metrics. So we took the cache statistics dashboard and actually send those out across to our metrics and monitoring system. So you can see, it looks like September 15th, we were having a really bad day because the air trap count jumped past 5,000 when I took that shot, right? So something went wrong. That's critical. That probably raises alarms and all sorts of stuff. So these feel very different than how many calls am I making, how many customers are on the system. These typically have alerts associated with them. And that's one of the other things that we found out about is you need to have your alerts in such a way that the people who are awake can respond to them, because oftentimes these happen, say, at 3 in the morning. So things like cache journal is running out of errors, or you're running out of space. Something actionable versus DB 402, exception error, something like that. So spend a lot of time defining what those alerts are, and then spending time actually talking to the people who will be around, your ops people, to figure out how to deal with those. It's pretty critical. And then you have your false positives, right? One of the worst things that you can have is people ignoring the alerts because they think they're not real. We've had situations with that as well. So we ended up spending a lot more time with metrics and alerts and monitoring than we'd have expected. And again, that's a pretty big difference between a premise type application and what this is. So fault tolerance, again, cattle over pets. If a cattle gets sick, we shoot it and get a new one, really easy. Defining a healthy state for your services is actually a really hard problem. And it takes your business side typically to go in and help you understand what healthy versus impaired and when you should shoot that cattle. Application metrics, so kind of group them between insight and health because they're different. And figure out how long you're going to keep them, or you can delete them after 3 months. What's your resolution? For example, we have 90,000 metrics with about 50 tenants currently running. And we have about 12 high-level services between making phone calls or SMS messages or various other things. I don't think that's the right amount. I think that's too many metrics, right? But having that discussion up front of monitoring how many metrics do you have. When you add metrics, what's the cost? Is it worth it? When you add the metric, is it something that you have an alert? Is it a health metric? Is it an application metric? All kinds of things that we didn't think about when we first went to SaaS, and we've learned through the process. And a test regimen for fault tolerance. It's just like performance. You can have the design where all of your stuff sits behind load balancers, and it's supposed to automatically fail over when it falls over, but it doesn't. So it's good to actually go through and test that and have that part of your regular automated test regimen. So we have automated tests that do functionality tests, we have performance tests, we have scalability tests, and then we have failover tests. And we run those with each cycle. So some other things that we learned. Everybody wants to automate once you get to the cloud. They want to use all the cool tools to get things up onto the cloud and just press a button and it all magically works. But we found out you shouldn't do that first. You spend way too much time automating things that don't exist, or you do it wrong, or you don't actually understand the problem domain. And what we've found is that we make someone do it manually at least twice. Do it twice, figure out the right way to do it, not just once, because you'll probably do it wrong, do it twice. And then from that point, you automate it. We've wasted a lot of time with people trying to automate first versus just testing it out manually. Deployment to SaaS. So the typical hello world program for most engineers, this is a pretty different environment. You could go into Iris and write a hello program fairly fast. And this one, that doesn't count for much because you haven't deployed it to a real environment. So once you get your hello world deployed, then you can move on with your project. So when we kick off projects in our SaaS environment, the first thing we make the engineering team do is take some code and push it all the way out to the QC environment. It can be as simple as hello world and everything else. And from that point on, they can start making enhancements and improvements. I'm pushing it at each sprint, running the tests, and you get a nice little rhythm about how you get new features in, a nice little agile process. But again, not something that people are used to. Development environments get really, really difficult when you go cloud. There's likely cloud services that you're going to rely on. So we rely on things like S3 or AWS Elasticache, various types of services. Those don't exist on your developer's laptop or machine. How are you going to make that work? Right now, our current cloud can't run on a 32 gig, 16 core machine. It's just too big for the stuff that we do. So you have to figure out an environment for that. For us, because we're using Docker and Kubernetes, they have this concept of namespaces, which allow all of our developers to run on one cluster. Right? That's what we ended up doing, and then we can use all of our services. But it kind of depends on what you do and how you move to the cloud. But having an engineering environment is certainly part of that plan. And you can expect to lose a couple of weeks of effort when you first get that stood up of how to get my engineers on a consistent process and environment across the entire time. And this last one's probably one of the biggest ones, is that everyone involved with the SaaS needs to know how to draw a topology picture. And I'll show one here in a second. And that's basically, how does everything talk to each other? It's not your typical picture that you see, which is with a big box with smaller boxes inside of it. And those smaller boxes are each modules, right, that talk to each other. Let me go to it. It looks more like this, right, where you have various services running across the network with message buses, and you figure out how the messages go from one side to the right side and so on and so forth. That way you know if one of your, say, your text sender services goes out or you're having an issue with your alert, you actually know what the problem is and know what the effect. And we've actually taken this a step farther. We've taken diagrams like this, and when we have our alerts, they actually show up on a picture like this, right? So instead of saying, hey, I have cache errors, or I'm out of disk space, it's, hey, the text sender stack is having problems. And then anyone can go say, oh, that means that we're not sending texts, right? That may be a little obvious. But in some other type of situations, it's not nearly as obvious. So having people understand kind of the topology and the pictures, and knowing when you have a problem, what it means is a big change from on-premise. Okay. So how did we use InterSystems technology to do all this? It's used throughout our entire stack. So we're using Iris containers for Kubernetes. We only deploy containers in our current cloud stack. And we have them all self-configuration. So when those Iris containers start up, there's environment variables. That means they hook up to the database servers over ECP. They set up their journal stores, all that sort of stuff is automatically configured. We use ECP application servers for cattle. So we have multiple app servers. If one of them dies, we can spin up a new one. Doesn't hurt anything. So we're really happy with adding more ECP application servers or adding more namespaces in those ECP app servers. The database servers are our pets. Those are mirrored, of course. So we spend a lot of time making sure they're healthy, and we haven't had a lot of issues in production around that we haven't caused. We've caused some problems around that. You saw how we were leveraging InterSystems metrics to our metrics, so we could see things like air traps and journal usage, that sort of thing. We leverage multiple namespaces, so our microservice infrastructure and InterSystems technology looks like a namespace per microservice for that type of technology. And those are pretty small programs, they're pretty easy to install, pretty easy to understand. We build Docker images for all of our compiled code. So when we want to upgrade a new instance, all we do is start up a new Docker image. There's no install program, there's no XML loading, there's no compilation, which means that we can actually upgrade in seconds, typically, as we move our various servers and some various things. One of the things that Kubernetes allows you to do is have something called canary deployments, which allows you to test a couple of containers for certain tenants to see if it's working pretty well, and if it is, and you roll out across the board. So we also leverage that as well. So we're able to kind of test our rollouts to the public cloud without bringing down everybody if we do have an issue. That kind of goes back to what healthy is. So if you bring something up and is it healthy or not, it goes back to our metric discussion. And then we store our DATs on cloud file systems. In our case, we use AWS EBS volumes. And one of our architects has joked about this, that it means our pets are more like goldfish. And what he meant there is that you can replace a goldfish before anybody notices, even if it dies. So with Kubernetes, we've lost pets. We've lost both of our pet servers. Kubernetes and Docker and containers has self-healed that. ECP servers has kept the application servers running. It's been a really resilient solution for us in the cloud. So, questions?
How long did it take?
That's 6 years, but we made a lot of mistakes along the way, right? If I had this information now, we probably get done in a couple years at this point. A lot of learnings there.
Can you talk about the impact of business, either in terms of being able to be more responsive to your customers, to implement functionality faster, or maybe operationally being able to do more with the development teams that you have?
Yeah, absolutely. So it's been big wins for us across the board. Operationally, not having to worry about a network stack failure and someone to have to go unplug a wire, which happened to us when we host customers, and dealing with all that. You do have to deal with AWS servers will go down, so you always have to plan for that, right, for that to happen, but we built that into our solution. So we've saved a lot of cost savings around operations by pushing that kind of hardware type stuff off to AWS. And it's a lot easier to scale. So versus waiting, a month or two possibly, or weeks to get a new machine up for a new tenant, we just auto scale as we add tenants to our cluster, which makes a huge difference. We've been able to leverage a lot of technologies in the cloud, right? So as in our case, as AWS adds services, we can expose those to our customers through our interface, and they can leverage those. So for example, AWS sends text messages. That's how we leverage some of our SMS type stuff for our messages. And we're able to get that done in weeks versus, hey, you have to wait months of coding across multiple products, and then you have to ship it. Instead, it just shows up at the customer site fairly quickly. So it's been pretty radically transformative for us for both how much are we spending on ops, how fast can we get things to market, and then we don't have to maintain all the different versions of our core products on premise. So it's been pretty radical for us, and it's our way forward for all of our new features and our platforms. Sure.
Do you ever run out of capacity on the machine itself that you have to adjust or create more resource on the machine? How do you provision that?
Typically, we have it set to auto scale, so we have a certain size machine, and once we get past a certain limit of CPU or memory usage, the cloud will automatically scale up a new machine, and then Kubernetes will allow us to just, those clusters, nodes will actually move to that new machine. So it's touchless from our point of view. Okay, thanks.